Hi everyone. So who here caught a train this morning? Very good. I hope it went well if you did. Obviously last week we had some problems with the train services, but at least with the weather we can predict it a few days in advance and react to what's going to happen. Sometimes we can avoid problems entirely. So my point is that being able to forecast things is equally useful on the railway. And how do we do this? Well, the obvious answer is to look at the timetable, but how do we know that the timetable is accurate? In a lot of cases, it might not be. So the timetable is not always perfect. Last year, Network Rail paid 23 million in fines to Great Western for delays, and at any point in time, only about a quarter of Great Western trains are within a minute of the timetable. So there's clearly some room for improvement here. Imagine if we could simulate perfectly what was going to happen on the network. We'd be able to perfect the timetable, reduce delays and reduce these fines. Controllers would have a much clearer idea of what's going on, and we could identify problems and bottlenecks in infrastructure before they create delays. So I've been working with a traffic management company called Resonate, who have a long history of working in the signaling industry for the railway. And they're rolling out a software platform later this year called Luminate. A key part of Luminate is a forecasting engine which builds upon Resonate's signaling experience. But even with the best signaling understanding in the world, if you're not exactly sure where the trains are, you're going to have problems. Because if you think two trains are going to meet at a junction and a signal is going to have to decide which one to let go, but actually they never meet because one of them's delayed by a few minutes, then your forecaster is going to diverge from reality at that point. So it's really important that you can model every stage of the journey as accurately as possible. And that's where I came in. My name's Tom, I never said that. So I was looking at berth crossing time. So berth is the smallest length of track, and we call the length of time that it takes a train to go across that the berth occupation time. And because of the digitization of the railway in recent years, we've now got quite a lot of historic data on how long it takes trains to go across these small sections of track. And this is the kind of screen that a controller might see. So you've got a bunch of berths, which are the black rectangles. Some of them have trains in, and then you've got the connectivity between them. So I took a lot of these berths between London and Bristol, and I fit models to them using the historic data for different journey types and days of the week and all this kind of thing, for how long it takes a train to go across each berth. Because if I can time each berth individually and stitch them all together, then I can have a timeline for the complete journey. The berths in green on this map, the green circles, I was able to fit models to. The ones in red were a bit more tricky. Most of these are around stations or the approach to stations. And Luminate already has an understanding of the signaling, so it deals with these pretty well. So I don't include them in my comparison because I'm really looking to improve on the existing system. So I'm looking for kind of a complementary approach. So if we look at a normal train journey, we've got distance versus time. So this is a real journey from sometime last year. And we can see that the existing forecasting system, which bases its ideas on the timetable, gets this wrong. Not by much, just by a couple of minutes. This is actually because the train was delayed. So it's not a big deal, but in a forecasting system, this can be a problem if you get into the situation I mentioned before, where you think two trains are going to interact, but actually they don't, because one of them was held up for 5 minutes and it's not even there. But if we contrast this with my models, which use the historic data, then I get a much more accurate forecast across the berths where I have a good fit. And I've cherry-picked this example because it's a nice example. But it does generalize as well. So this is a graph of predicted versus real berth occupation times for a whole bunch of berths and a whole bunch of journeys. And this is the existing forecaster. So ideally, everything would lie on this dotted line, but there's quite a lot of scatter. But if I include my models, it gets much more accurate. So we have a much more realistic prediction of how long it's going to take a train to go across a section of track. So the plan is to combine this with Resonate's existing forecasting system, the signaling logic. So I took these models and I packaged them all up and I put them behind an API, and Resonate are working on querying this API from within their system. So they don't have to do a lot of development work to include this, and we can tweak the models and improve them without affecting everything. So it's kind of modularized in a nice way. And if we can combine these two systems, hopefully we can move from this kind of situation, which is all too common, into something more like this. So, thanks.